Okay, for today's lesson, you're going to look at identifying, but then also solving similar figures. In particular, we're going to look at triangles. We started off and we kind of did a little bit of exploration, so I'll just recap for you on this. Feel free to go through these questions on this first page on your own, kind of take a look at it. But all rectangles are similar is not a true conjecture, so meaning like statement. All equilateral triangles are similar is true. All isosceles is not, and all squares are similar. And the reason is because when you do a dilation, you have to dilate the sides by the same amount. So like if we look here when they're thinking about the squares, they start off and they have this rectangle, not square, a rectangle A, B, C, D. And they go ahead and they put it over here, so you've got like A, B, C, D, right? And if you draw the square inside here, you'll notice that as I go through, so that was maybe it was not the best picture, but as I go through, then, I'd have to dilate the top and the bottom, like more than so I'd have to extend it more to the right than I would going down in order to have it fit inside that other rectangle. So therefore, they're not similar, meaning, hey, remember, similar we defined as like the same shape, but not the same size. So once again, while they're both rectangles, they're not exactly the same shape. Whereas when you do it with a equilateral triangle, right, we put that triangle inside here. As we extend it, it will dilate by the same amount. Okay, so let's actually look at some of the math we're going to do today. We started today, and we looked at just solving some proportions. We're going to be using these a lot in the next couple weeks. So the easiest way to solve a proportion is to cross multiply. So 3 times 7 is 21. 8 times x is 8x. Solve for x, we're going to divide both sides by 8. You're welcome to either leave that as a fraction, or I know a lot of you like decimals. So 21 divided by 8 is equal to 2.625. Okay, we rewrote this one because I don't think people like parentheses generally, so we distributed the 2 in the parentheses first. We got 2x plus 8 over 3. Then we treat it the same way. We cross multiplied, right? So 9 times 2x is 8x. And the tricky part here is you also have to multiply 9 times the 8 to get 72. So that 9 will multiply to both parts. Then we have 4x times 3 is 12x. To solve for x, we subtracted 18x from both sides. 72 equals negative 6x. Divided by negative 6, x equals a negative 12. One more here. Cross multiply. So remember that 9 will distribute to both parts. You'd have 9x minus 9 equals 7x plus 28. And you want to get your x's on the same side, so subtract 7x on both sides. So 2x minus 9 equals 28. Add your 9. 2x equals 37. And then divide 37 by 2. And once again, you could leave it as a fraction, 37 halves. Or I know a lot of you like decimals, so we get 18.5. Okay. So as a reminder for you today, similars are the same shape, but different size. And the symbol we use is that little like squiggle line. Similar triangles are triangles that have 3 pairs of congruent corresponding angles and 3 pairs of proportional corresponding sides. Reminder that corresponding means they're in the same position. And proportional means that the sides will have the same ratio. So if we look down here at this picture, they're saying A corresponds with D, right? B corresponds with E, C corresponds with F. You have the sides they wrote as proportions. So if we talk about triangle ABC, we got to do the other triangle in the same order, so is similar to triangle DEF. Okay, on these next ones, it says find all the missing sides and angles. So we've got 75 here for J. It says triangle JKL is similar to MNO. So J is similar to M, so we got 75 both there. That's good. K is similar to N, so that means this has to be 60 as well. To get the other side, we could do 180 minus 75 minus 60 equals 45. So that means the last angle in both these triangles has to be 45 degrees. As we think about solving for the missing sides, I think a lot of people still think about it as like a scale factor. So you could say, okay, well, to get from 9 to 3, I divided by 3. So then to get from 6 to this side, if I divide 6 divided by 3, I'd get this side is 2. And I could go the opposite way here. If this side is 1, I have to do 1 times 3, and I'd get 3. So we thought about those as scale factors. As we take a look at this next one, we're just going to write the similarity statements to make sure we understand what similar triangles are. So if you've got angle Q, that is congruent to angle X. If you've got angle Y, it's the second letter, it's congruent to angle R, is the second letter. If I even use 3 letters, so R, S, Q, I'm going to follow the same order on the next one. So the second letter is Y, last letter is Z, first letter is X. Okay, QR over XY. Those sides are going to be proportional. RS, last 2 letters, is proportional to YZ. Last but not least, SQ is proportional to ZX. Okay, so just like you had last year when you had like, hey, side, angle, etc., that proved that triangles are congruent, we have things that will prove triangles are similar. So you don't have to know all 6 pieces of each triangle, 3 angles and 3 sides to prove that they are similar. There are shortcuts, just like you had last year. So side, side, side will prove that they're similar, but it means that all 3 pairs of sides are proportional. So what we mean by that is if I take 10 divided by 5, those are corresponding sides. Or if I take 8 divided by 4, those are corresponding sides. Or if I take 12 divided by 6, each of those give you the same ratio of 2, right? That ratio is always the same. Okay, if we say side, angle, side, we're saying the 2 pairs of sides are proportional and the angles between them are congruent. So we're saying, okay, like 9 over 6, because those are the sides that correspond, and 6 over 4. And either way I divide those, 9 divided by 6, 6 divided by 4, they both give you 1.5. So they have the same ratio. And then we see here that they mark the angles are congruent as well. Last but not least, you've got angle, angle. So it means that 2 pairs of angles are congruent. And you know if 2 pairs of angles are congruent, then all 3 will be congruent. Because, for example, right, if you had a 20 degree and then a 60 degree, because it's a triangle always adds up to an 80, you know the other degree has to be 100. So let's look at these examples and decide, are these triangles similar? If so, you got to tell me what shortcut proves it. So we got a set of angles. And looking at the diagram, we also have vertical angles. So these triangles are similar by angle, angle. As we take a look at the next one, we're going to want to check. It looks like they have the sides labeled. So we're going to check the proportions. So it doesn't matter which one you start with, but if I start with 7, I got to start with like the left triangle on the top very one. So 7 over 5.25. And then I would do 12 over the 9. And then 14 over 10.5. And then you want to check each of those ratios. So this first one gives us 1.3 repeating, or 4/3. 12 over 9 also gives us 1.3 repeating, good sign. 14 over 10.3 gives us 1.3 repeating. This one you probably had to check on your calculator. So yes, hey, all those are equal. So yes, these triangles are similar by side, side, side. Okay, last but not least, we got some sides we could check, and we got an angle. So it's looking like it's side, angle, side. But the only issue is we don't have another side here, right? We don't know anything about the side in the middle. So therefore, we say that there's not enough info. Meaning, hey, it is possible that they're similar, but we don't know the information you're given. First of all, it tells us the triangles ABC and triangle DEF are similar. So it first has to solve for x. So you got to ask yourself, D corresponds with what angle in the first triangle? A. So x equals 95. You can do a similar thing for y. As you look at y, it goes along with angle F, which corresponds with angle C. So y equals 33. So now it's about solving for the sides. So we're going to solve for the side Z. As you look here, you'll notice that side AB actually corresponds with side DE over here. So if AB and DE correspond, you'll notice now all of a sudden your scale factors are not quite as nice. You can still figure it out and say, okay, well, what do you multiply 5 by to get to 7? And I believe it's 1.4. So you could do something like that. However, they're not as natural as they were before. So you have two options. You could do what you're kind of doing, saying, hey, find the kind of the scale factor, use the idea of last time, or you could start setting up proportions, like 5 over 7 equals, in my smaller triangle I got Z over 15. So now, as you cross multiply, 5 times 15 is 75, equals 7 times Z, which is 7Z, so divide both sides by 7, and you get Z equals approximately 10.71, and that is rounded. Okay, let's do it on this next one. So once again, we're looking for X and Y. Y is probably a little easier because we're talking about the angle, so angle M. If you look at here is the first letter, angle J is the first letter over there, so it corresponds to J. So Y equals 72. Okay, to look at your sides now, NO corresponds with KL. So these two sides correspond. So once again, you could say, well, 10 times what gives me 1.3, say something like, hey, this is a scale factor of 1.3, so I can do 8.5 times 1.3. And that totally works, but you'll notice that these scale factors just aren't quite as nice. So I think it's good to start getting in the habit of doing proportion, not to say it's the way you have to do it. As long as you can solve for X, it's up to you. So we've got either X equals 1.3 times 8.5, which is 11.05. Or you could do something like 10 over 13 is equal to 8.5 over X. Do your cross multiplying, and you'd have 110.5 equals 10x. Divide both sides by 10. Either way, you get X is 11.05, so pick a way that works best for you. Okay, two last problems here. Okay. We want to find, it says a bush set on the other side of the canyon, find the width. First of all, I'm kind of assuming a few things like, hey, you've got a right angle, and these vertical angles are congruent, so we've got angle. So these triangles are similar. I think here people do like to think about scale factors. You're kind of in your mind going to have to think about like rotating this triangle over here on the left a bit such that you're saying, okay, this bottom is 10, and this is 7.5. So the 10 and the 100 correspond. So a lot of people see that as like, hey, this is times 10. So for most of the students, what they did is they just said, okay, well then 7.5, if I times that by 10, maybe I should do a little dot, sorry. We'd get the other side length is 75. The width of the canyon is 75 feet. You'd be welcome to set up a proportion as well. Okay. Last but not least, you got two ladders that are leaning up against a wall that make the same angle to the ground. So you got a wall, you've got this first ladder, and it's making this angle with the ground, and you got a wall, and then the same angle, but you got a second ladder. Okay, not necessarily drawn to scale. The 10-foot ladder reaches 8 feet up the wall. So 10-foot ladder, so that's going to label the hypotenuse there, reaches 8 feet up the wall. Whereas the 18-foot ladder, we want to figure out how far up the wall this reaches. So once again, it's up to you. These are similar triangles because you can assume there's a right angle there, and you've got another angle that's congruent. So you're kind of saying, well, how do I get from 10 to 18? I multiply times 1.5. If you can recognize that and kind of think about the scale factor, then 8 x is going to equal 8 times 1.5. Otherwise, you could set up some type of proportion. So here we do get a total of 14.4 feet. Good luck with your assignment today.